Hi, my name is Jyotsna Joshi, and I'm a systems engineer at Collins Aerospace. And I'm here to talk to you today about my journey as an engineer so far, what I do as a systems engineer at Collins, and how you might start looking into science and technology as a career today. A little bit about me to begin. I recently got my degree in computer engineering at the University of Illinois at Urbana-Champaign. That degree allows me to work with things that are a little bit computer science, a little bit electrical engineering. So it allows me to work with robots and sensors, which I think is really cool. I love traveling. I got to go to Oregon with my team as a part of my job, which was really interesting and I hope you'll learn about in a little bit. And I love to bake and cook, and that comes with the bonus hobby of eating. Can never go wrong with that. My engineering journey so far um, has been focused on machine learning and autonomy. I've always wanted to work with space and aviation. I started working initially at Procter& and Gamble, which is the company behind Head& and Shoulders, Bounty paper towels, Crest toothpaste, Oral-B toothbrushes, a lot of these household products. And I started as a machine learning intern at producing Bounty paper towels, and I really enjoyed that actually. So I took another job there the following summer working as an IoT intern. That's Internet of Things, which is when you get to deploy sensors in an area and collect a lot of data about how people interact with things in that area over time and hopefully try to make some helpful conclusions about the data from what you've collected. So I was working on helping people deploy sensors into bathrooms so a Procter& and Gamble could assess how well people are using their shampoos, or if people could see how fast am I actually using my toothpaste? Is my toothbrush actually helping me? Is my body lotion actually good for me? Is it helping my skin? That kind of stuff. Out of these two experiences, I got to start working as a systems engineer at Collins Aerospace, initially as a co-op, which is a long internship, and then I accepted a full-time position. Quickly about systems engineering, which is such a broad field that I feel like I can't get to all of it right now. But I think broadly to me, systems engineering is about starting from the beginning of kind of the engineering process and working your way through the end. So starting with when someone comes to you and says, "Hey, I have this problem," to actually helping them define a solution for it, define what they think they might like to see, and then working with multidisciplinary teams. So aerospace, mechanical engineering, computer science, electrical engineering to actually get the product built from this high level from the beginning all the way to the end, where you actually get to test your product and see if what you designed and what you ended up building, how closely they match and how well they solve the problem. That is what I get to do for autonomous drones. As you can see here in the bottom right, we build these autonomous drones that people like pilots who fly helicopters in kind of defense applications can deploy these drones into areas that they might not know a lot about. So if there's like a big hill in the way, or if there's someplace that they know that might not be safe for them to go, a pilot can deploy these autonomous drones that work with each other in a team to learn more about the area and report back that information to the pilot so they can make a safe decision or a helpful decision. I think that that's really interesting for me because one, because of the autonomy part itself, the robotics part of it, the system that thinks for itself part of it is so fun. But then I also get to do a lot of different things within my job. So I get to work with hardware and software, and I even got to go out with my team to Oregon to actually try some flight testing, which I think can be really cool to see the work that all of us have been putting together actually, sort of start to come together in front of our eyes. If that sounds interesting to you at all, you might be wondering, how can I get started? I think, especially at the middle school level, but then also going into high school, getting a really good base set of experiences is really important. I think the more experience over time that you have with the material, the more fun it is actually to be an engineer because you have so much that you know, and then I feel like engineering is about applying what you know into a problem space and actually trying to come up with a really good solution that helps the people in that area, or actually solves a problem that you're experiencing. And I think that it can be really fun when you have a lot of this information that you can pour into your project. So I think that starts in school, getting a really good, solid foundation in your science and math classes, but also going outside of STEM and picking up hobbies like music or art or writing that really inspire you to think in different ways and look at different aspects of our everyday lives that you think that you might like to contribute to. I think another good thing to do is get outside and go to these museums and planetariums, aquariums to get a sense of what people have collected as knowledge so far and kind of have that awareness of the scientific knowledge we have. And I think a really fun thing to do, a really easy thing to do, and a really engaging thing to do is consume media, right? So I think games, sci-fi books, TV shows, movies, they have so much information and so much imagination about what the future might look like, what technology might look like for us in the near future or even in the far future that people really get inspired by it and start to work on building this technology. One of my favorite stories is from Fahrenheit 451, where they describe a woman who puts in these little thimbles in her ears and she can hear music and nobody else can. And at that time, it was like this really futuristic thing that people hadn't thought about or had no way how that could be real. And some engineers read that and were really inspired. And over time, over decades of engineering and science research, we have AirPods today, which is exactly what Ray Bradbury was describing then, but at that time had no way of knowing that they might turn that into a real device. And I think that that's really beautiful. And I think getting involved in non-STEM activities can help you kind of get that imagination, and media can help you see how it might come to life. I think another thing that I did was get involved in science and math competitions, and robotics or other sort of outside of school activities that help you build your experience in actually applying these techniques. I think that this you can start doing at any time, whether that's middle school, even elementary school, but high school and university you can start out with these project teams at different levels that really help you bring your knowledge from kind of the textbook to the real world, right? Then you get to start actually seeing, wow, what does it take to build a robot that's 6 feet tall that actually has to move around and while it's heavy, how much power does it take or what's safe and does it catch on fire, right? Like those are real things that you have to think about in the real world, that you might not learn in school that you can get experience at by doing these projects. And I think the more knowledge you gain and the further you get in your education, the more specific you can be about the kinds of projects that you want to work on. These are some things that I did that I hope that you can take a look at and maybe start to think about as things that you might like to do. You can see that non-STEM things have been helpful to me too. Speech and debate is one of the things that I really enjoyed doing that helped me become a better communicator, become a better um, engineer on my team, to be able to speak on what I'm doing and to be able to understand what other people are saying to me. So I always encourage people to look outside their STEM interests too to gain these other skills that I think really make an engineer. But with that, there's so many challenges, right? I think with engineering, it's such a broad field with so many things that you can do that there's mind-boggling amounts of options. For that, I would say it really helps to think about the end goal or a job that you might like to have or a problem that you might like to solve. So if you know, like, hey, I'm really into space or I'm really into art, I'm really into music, if you can start with that and then kind of look at what other engineers in that space are doing and how they got there and work backwards from there, then you can sort of be like, oh, maybe I want this kind of degree, and maybe I should take these classes in high school that would help me get that degree, or get into a school that would support that degree. That kind of thinking to keep going backwards with that until you hit your present day. And I feel like then you kind of have a vision for what the path forward might look like. I think the key thing about that is that you don't have to know today. It just this is an exercise that I do to help me think about what I might like to do. I think as long as you keep reevaluating and checking in with yourself, like, hey, is this really still what I'm interested in? I think that that's a great way to keep going forwards. The difficult part can be to see other people like yourself walking this path, right? Getting further into their own engineering journeys, especially if you feel like being an engineer, it's not for somebody that looks like me or somebody that presents like I do, somebody. that is from the background that I am. I think that seeing other people who are achieving what you want to achieve or who are working on things that you find cool can help you get there. And I think that doesn't have to be somebody so much older than you. I think, especially at the high school and university level, there's all these organizations. These are all professional organizations that I've listed that have chapters at local universities and colleges with young people who've just started their journeys too. And I think trying to get connected to them or at least observing their lives to see what you might like to do can help us feel like there's a path forward for us too. I think the most important thing with that is to take your time by looking at other people or looking at your own self. It can be easy to feel like, oh, I should be somewhere else that I'm not right now, or I'm further behind than I am. And that's not necessarily something that you should feel rushed about as long as you have a solid base, as long as you feel like this is really something that you're interested in and that you take your time to learn the material and learn your skills. It's always something that you can keep going with. And I think continuous learning really helps with that. I think learning how to teach yourself something new can help you keep up with the pace of innovation that we're seeing today and can help you feel like, yeah, I'm keeping up with the technology at least, even if not with the other people that you're seeing. At least within yourself, you feel like I'm improving my skills as an engineer. I'm improving my skills as a scientist, as a researcher. And learning these little things can help you hit that spot in your brain that loves to learn. I feel like anybody that's interested in STEM loves to learn and put things together, and can help you keep moving forwards down your engineering journey, your STEM journey. And I think the key with there, like with everything I've mentioned before, is to start small and get bigger over time. Here's some resources that might help you do that. I think getting started with your own projects today would be really helpful. I love all these podcasts and YouTubers and science history books that tell you about what we've done so far, fun ways to tackle problems that we see today, and kind of the vision that people around the world have for the near future and far future. I think in terms of getting hands-on experience, summer camps that, especially in a lot of areas, are free if they're hosted by local universities or high schools, can be invaluable in gaining experience, hands-on experience, with instruction from people who are comfortable to talk to or who have experience teaching younger people or people who are newer at something can be really helpful. And always there's a wonderful community support for starter kits, right? Like what I mentioned at the bottom, Adafruit Young Engineer kits or Arduino starter kits come with a lot of projects that you can get started on, and a lot of the internet is available to help you do it. I hope that that was helpful. Good luck, have fun, and I'd like to leave you with this thought that the journey ahead is long, but like Edison has said, I have not failed, but have found 1,000 ways not to make a light bulb. Every step we take in our journey is fun and helpful and productive, and I hope that you can keep that in mind as you go down your engineering path. Thanks.